Hey, hello, and welcome to the show. It's me, John Park. I am here for my workshop, for John Park's workshop, and I got sidetracked there because I was saying hi to people over in the Discord, and I didn't get to type everyone's name in because then my song stopped there, and it was time to start the show. But I will continue this live. Hello, Jim Hendrickson. Hello, Thin Man. Hello, Johnny Bergdahl. Thanks for joining us over in the YouTube chat. Hello, Beata Graf Aldehagen. Hello, Dave Odessa. Hello, Toasty French. And Johnny Bergdahl appears there as well. Probably the same person, right, Johnny? Well, this is our Discord, if you're wondering. You can head over to adafruit.it/Discord, jump into the live broadcast chat channel. You can see we have a bunch of different channels there for different needs, for different chats about different topics. But live broadcast chat is where it happens during the shows. More CRTs, probably. Actually, you're right. There is. There's one more. We're going to talk about a CRT today. Want a glimpse of it? Uh-oh. Camera switcher's not working. Is it? Hey, what did I break? There it is. What was happening there? I don't know what was happening there. Is my software rebelling? I'm back. It's there. Yeah, so we're going to talk about that little tiny CRT today. What else? Johnny Bergdahl says, not saying I'm the same person, but there are 3 people with this name in Sweden. You are legion. Good grief. So, hey, Todd noticed, hi TodBot, Todd noticed that I am in 1080p. When did that happen? Gosh, I'm going to forget now who was it that asked, but someone during either this or the Tuesday show said, hey, would you consider trying 1080p again so we can read the text on your screen? And you'll notice, oh, that's what happened before I had this screen up. You'll notice here, this should be pretty sharp if you tell your YouTube to watch this in 1080p or other services if they let you select instead of just auto throttling or whatever it's going to do. But if you pick 1080p, you should see this is pretty crisp. I started doing this maybe a couple months ago. I had done 1080p a couple years ago. Then I had a whole bunch of what I thought were bandwidth issues, which may have been other issues I don't quite recall anymore. And when I got that request maybe a month or 2 ago, I tried it, and I think now I've got both these shows in 1080p. Maybe it's just this one. I'll check. But yeah, thanks, Jason Edelman. Says it's looking pretty sharp. You can see Lars more clearly. Where is Lars? Oh. Oh gosh, that's way too much, Lars. We'll set you over there. Much clearer though, yeah. So what's going on here today? I have a show. This is the show. I have a coupon code for you so you can save some money in the Adafruit shop. As you know, Selling stuff is how we keep the lights on at Adafruit. It's how we keep developing open source software and hardware and drivers and things and content such as Learn Guide, tutorials, videos. How we put all that in the world, we sell stuff in the store. You knew that, right? But as a little incentive, I've got a coupon code for you here today, and that is Portable. Portable. Portable is the coupon code of the day. What that means is if you head over to the Adafruit shop and look at the cool stuff for sale there, you can use the discount code Portable as the coupon code on your way out as you're checking out, and you will save some money. And if you're wondering what to get, maybe you don't need 100 small anti-static pink Ziploc bags, but maybe you do. And those would cost you $3.50 normally, but with today's coupon code, that would be $3.50 minus 35 cents, whatever that math is. I don't know, $3.15, $3.25, who's to say? I can't do math. But if you go to the products menu here at the top and click on New Products, View All, you'll see the latest cool stuff in the shop. We've got these things. I've never tried these. Anyone tried these? Pixel Blaze. They are a hardware software solution for doing very cool animated NeoPixel and dot star effects with RGB LEDs, and they have some cool software apparently. That's what Lady Ada was saying. I have not looked into it, but doing animation on these, and I think you can use your phone app to update them and swap them and share them. So we've got those things, and they're still in stock, and you can get them for 10% off if you use that coupon code Portable on the way out today. We've also got a whole bunch of new things. These are on the way, these Pi cowbells that have cameras on them, but we got a whole bunch of cool stuff here just in the news section, and pretty much anywhere you go on the site you might find neat stuff that you want for your project, and you can get yourself that 10% off just by typing in the word Portable on the way out. And that is effective on stuff, matter, physical bits, no, physical atoms, things that we can ship you, which is to say you do not get the discount on gift certificates, subscriptions, or software, only on things. Todd over in the chat says, Pixel Blaze boards are really good. I'm actually curious about this. What's going on here? This one caught my eye. This expansion board has a what looks to be a 3.5 millimeter TRS jack, TRRS jack. I'm not sure. What's that for? What are you hooking up with that little thing right there? Is it an audio thing? Is it a sensor thing? What are they using that for? Looks neat. So anyway, that's the discount code today, Portable. And I say portable in quotes because the project I'm going to, or more the retro gear thing we're going to do today is a very semi-portable CRT. On Tuesdays, I've got my Product Pick of the Week show, and on that show, I like to pick a thing and give you a humongous discount on it. Spend about 10-15 minutes checking it out, demos, software, and you get a big discount. This week it was a 50% off just during the show, so you'll want to try to tune in during the show on Tuesdays. That's 4 p.m. Eastern time that takes place. And here's a little recap of this week's show. It is the Cricket hat for Raspberry Pi. Right here, there's a Raspberry Pi 5. You can see I have the Cricket plopped right on top. What I've got plugged into my Cricket are DC motor here. There is a hobby servo here. We could have up to 4 hobby servos plugged in. And then I have one of these 8 signal input outputs as a analog input that I'm using for a potentiometer, it's a little potentiometer breakout. So what I'll do is I'll just run a Python program on here. We have the Blinka libraries installed, and what that means is we can use all those great CircuitPython commands and libraries that you know and love. So if I run that, we've now got control of that servo and the motor speed, forward and backwards. We can stop it right there. It is the Cricket hat for Raspberry Pi. That was the one. Sorry, I hope there wasn't an echo there. Yeah, I had a, Johnny said it sounds like we're in a karaoke bar. My mic was on. I'm so sorry. I left the mic on and I have a monitor to listen to that sound. So that was the echoey version, but you can go on the YouTube or other places on the web and see the non-echoey version or the whole show if you want. Those are all up on our YouTube channel. My apologies for that. Baragraf of Delhagen in YouTube chat says, I still need to magnify 4x to be able to read the text, but it's not so blurred. Well, that's good. Maybe we can broadcast in 4K someday. Maybe. All right. So next up, let's do a little CircuitPython Parsec. CircuitPython Parsec. All right. So this is a brand new thing, right? Hot off the press. I just saw it last night. I set it up, tried it out, and I love it, and I want to share it with you. I'm clearly not an expert in it. I just started using it. But this is on the CircuitPython Parsec today. I wanted to show you the CircUp examples function. So if you're not familiar with CircUp, it is a way to install libraries on your CircuitPython device. So right now I have a Feather, what's this, Feather RP2040 plugged in here. I just put a little piece of acrylic over there so you can see the LED. You can see right now it's running a little blink sketch. So I can install NeoPixel library on here by doing CircUp install NeoPixel. No, I can't. CircUp install NeoPixel. There we go. And so that will install the NeoPixel library if it's not already there. It'll update it if it needs updating. You can use other commands for that. So if I take a look right now, I'm going to do a list of my CircuitPython library drive. And you can see NeoPixel library is there. But by default, I have kind of a hello world sketch running on my device, and I want an example of code that uses a library I've installed with CircUp. So what we can do is say CircUp example, and I'm going to say NeoPixel, and I can actually tab complete, so it fills in the rest, and then I'm going to do a slash and hit tab again, and now it's going to fill in all the possible examples that come with the code that are stored up in GitHub. So here you can see I've got NeoPixel Pixel, NeoPixel Rainbow IO, NeoPixel RPI Simple Test, and NeoPixel Simple Test. So I'll do NeoPixel Simple Test and hit enter. And what this is going to do is copy that Python script onto my device. So now if I list the contents of the CircuitPython drive, you'll see not only do I have code.py, but now I have NeoPixel Simple Test.py. So in my code editor here, I'm just going to open that up. Here it is. I can copy that and paste it into the code.py, hit save, and now we should see a different test on the board there. Now I'll do the same thing with the NeoPixel Rainbow IO library. So I'm going to tab complete up to here and use this Rainbow IO. Simple test, hit enter, it copies that script onto my drive. Now I can open that one that also lives on my CircuitPython drive now, and I know you don't see the file window here, but I'm grabbing it. You'll see it open right here. So now again, I can copy that, paste that into code.py. I'm just going to set the number of NeoPixels to 1, and the pixel itself is on the board NeoPixel pin. So you may have to do some updates, but you've got these great examples. I'll go ahead and save that now. Now you see we're going to be fading around the color wheel there. This is fantastic. This means that when you install a library, you don't have to open up a browser, go find the GitHub for it, look for examples, or go to a different website and find them. You've got them at your fingertips using CircUp. So you can go to the, let me find the URL for you right here. If you go to github.com/adafruit/CircUp, you will find an example of how to use this, and you can upgrade your CircUp so that it'll be ready for this latest 1.8.0 feature, which is super, super cool. And so that is how you can use CircUp's example function inside of CircuitPython. And that's your CircuitPython Parsec. Sorry, echo was back, right? Batagraph asked, what are you using for an editor? This is Sublime Text that I'm using here. And it has, I think Terminus might be an add-on, but that just gives me a shell. So the thing on the bottom there is just a regular terminal shell. There were a couple of things that I needed to do for tab completion to work, and those are in the GitHub repository that I mentioned. In fact, let me show that right now. I'm going to head over to my Chrome window. Let me go find that. Where are you, Chrome window? There you are. And you can see here, library name autocomplete. This will work for libraries as well as the examples. And so there are, depending on the shell environment you're using, you can copy and paste into your, I did it in the Z shell RC setup, eval this statement here. I can zoom that up a bit. And there was a little extra setup that I needed to do to make that work that is outside the scope of this. But thank you, TBot, who helped me out figuring out a couple things that were missing in my shell. If it's at all helpful to anyone, and for posterity, I will show you. Let me go back to this window for a second. I will show you what my shell looks like. Z shell RC. Ignore this export prompt. I can't remember what that's about, but eval autoload _uz comp init eval comp init. Had to do those first, then it's able to run this in a new shell. You'll refresh your shell, and then the autocomplete here for CircUp will work. And yeah, like I said, check out that right there, and you will just need to update to the latest. You can use pip install upgrade CircUp, I believe, and those are instructions that you'll find there as well. So that is super exciting. I'm really happy to be able to do that. Really cool feature. There was another feature that Foamy Guy showed last night that's not quite out yet. That is a shell style file browser. Really nice old school shell file browser that gives you a little bit of a more visual approach to doing this, but without having to be in a graphical user interface. Let's see, so some comments over in the Discord. Some nice says, I understand why you might not want it to write over the current code.py file, but that might be an idea for an option. Yeah, that's cool, overwrite. I don't know if it is. I don't think Foamy Guy showed anything like that last night. I think he was just copying it there and then copying it, or having it write it onto the drive and then copying it, but that sounds cool. Yeah, some other discussion from Tyeth about ways to do this as well. Import example name pi from the REPL. So very cool. I'm excited about that. Thanks to everyone who works on those. Those are great. All right. So next up, I am gonna just go over the Learn guide for the PlayStation controller. So if you've been here the last week or two, I was working on this PlayStation controller. I've got it right here, and this thing is great for emulated gaming. I've been using it, particularly play through Micro Mages, which you know I love for NES. You can see it there in the GIF. It looks a little nutty, a little frantic. But the guide here will show you all you need, which is an ESP32 Itsy Bitsy. I'm using the LiPoly backpack add-on that works for ProTrinket or Itsy Bitsy as a battery charger, using a little 350 milliamp hour battery. You can actually use the short cable one for this. Excuse me, I changed the design, so I'll update that. You can use either the long cable or the short cable version. I believe the short cable version might be in stock even though the 350 long cable version is not. You may also be able to fit a larger battery if you're willing to cut more plastic and do some different arranging in there. I think I've seen an example where someone had a 500 milliamp hour battery in there, which would be terrific. We get about 3 hours of playtime on a charge with this battery based on the power monitoring I did. There's the little USB-C breakout for power, just for charging the battery up, and we're using the Wi-Fi built into the Itsy Bitsy to do any firmware updates after the first one. So you can, I wrote this in Arduino, you can plug it into your USB cable, compile, upload. From then on, if you've given it your Wi-Fi access point, SSID, and password, you can, when you start it up, go to the esp32.local web page, as long as you're on the same network, and send it a compiled bundle of code as a little bin creation function in Arduino that works really well. The wire wrap wire here in multicolor is super helpful for keeping things straight. I've done these kind of projects before where all I had was blue, and you start to lose track of which wire is going where. And then a PlayStation controller, and the style is essentially the one that came out when the US PlayStation launched. There was a previous version, I think it's the SCPH 1010 for Japan. It's a little smaller than this, so the one in the US is a little bigger, and it's, if you're in the US, the one you're probably going to be most likely to find. I think if you're anywhere outside of Japan, you're most likely to find that one. So that's the one I used if you want to use the identical one there. And then we have Arduino set up. I won't go over that. That is just one of our sort of boilerplate template pages for how to get the ESP32 Itsy Bitsy up and running in Arduino. Then we have the controller circuit. So this here, I don't know if I've shown this before, but this is, I took a photo of the PCB that's inside the PlayStation, and then I used the continuity mode of a multimeter to figure out what went where, which traces were for which of the little contacts that the buttons press. And on this version of it, there are, and I think there are versions that might not have it, but you can see there are little test points. So I think this is the first revision of this controller. There are little test points for every one of these buttons, which is fantastic. I think on some later ones you won't find that, and then you'll just need to scrape a little bit of the solder mask away. So it'll be a bit more involved. But if you, I don't know if there's a way. There's photos in my guide of the back of my controller. I don't know if there's any markings on here that indicate which one is which. But those are, excuse me, really helpful to have those test points on there. So I also sort of color coded. This was not the exact colors that I had in my hookup, rainbow hookup wire, but fairly close to this, again, to help keep straight. And then I have a fritzing diagram here that'll show you, oh, that's a little too big. That'll show you the circuit here. So I've got the ESP32. Most everything running to it is buttons. Then we have the USB-C breakout that I'm using to charge the battery through the LiPo charging circuit there. I left one, I didn't need one more button. Maybe I should have hooked that up. Maybe I'll regret that. But since I was using the lower right trigger button, I think they call this shoulder and this trigger. So I was using that lower right one for the reset on the board. I wanted to be able to reset the board externally. I left this one free, but you do have enough pins on the Itsy Bitsy if you want to map that as well. I'm using this mostly as a SNES style controller for my emulator. And then here is a more traditional schematic that may be helpful if you're trying to figure out what's connected to what. I used little net label names here to keep it somewhat neat, and you can see all the different pins that things run to. A lot of the time I spent in development was simply figuring out which GPIO pins I could use, because we want to have one of them be a real-time clock GPIO, which is what the ULP coprocessor on the Itsy Bitsy can watch when it's in deep sleep. So there's a little coprocessor that can watch certain pins, and it sips power. It does not use much, but it does need to be on. And so you can pick, I think there are 10 of them or something that are available, so you've got your choice. But I knew I had to pick one of those. Most of the other pins were fine. There were a couple that seemed to be acting a little flaky on me, so I noted that in the code. You'll see a list of the pins that worked out well for this, and there still are some spares if you wanted to hook up another. Speaking of code, here is the code. I mentioned at the top of this, the things you'll want to change are the SSID and password variables. They're right up at the top. And the sleep seconds variable. That's how long it'll take before it falls asleep based on inaction. So as long as you're, in fact, you can probably see this. If I touch the start button, you should see a blue light in there. It's glowing blue now. That means it's active, and any buttons I'm pressing prevents it from trying to go to sleep. If I stop pressing button, it takes 30 seconds and then it falls asleep. And you can change that here just with this int sleep seconds equals 30. And then later in the code, I multiply that by milliseconds so that we can get the proper time before shutdown or before deep sleep. And it wakes up pretty quickly on start button. So press the start button. I mentioned this in my power profiling section, but I will show you in the code this key thing. I can't remember if I showed this last week or not, but the power consumption was much higher than it should have been in deep sleep. It was 1.8 milliamps, and that was going to give us like 8 days of sleep, and it should be way, way, way longer than that, or much, much less power consumption. And after trial and error, getting rid of code, trying simpler examples, I eventually sought out the right thing in the Espressif documents to realize, since we have the Wi-Fi server on here that can be used for the over-the-air upgrades, we have to explicitly stop Wi-Fi before deep sleep. So ESP Deep Sleep Start shuts off a heck of a lot of peripherals, but for some reasons that I'm not clear on, and there may be some good ones, some people mentioned those last night, the ESP Wi-Fi stop needs to be explicitly called. In order to have that command available up in our defines at the beginning, we are including ESP Wi-Fi explicitly. Normally this ESP Wi-Fi stuff is a little lower level, and just the Wi-Fi library calls the right things, but I did need to include that in order to be able to call stop to the server, and it restarts the server. So the neat thing about the ESP32 deep sleep stuff is that when it comes out of sleep, it runs through the code again, so it will begin your Wi-Fi server anew, make a connection to Bluetooth. You don't have to do anything special. It just reruns the code essentially, almost like it's reset. There's also I don't need it in this case, but you can store values in non-volatile memory. So if you're playing and you had some state you needed to save and then it fell asleep, when it wakes up, you can save whatever that variable value is in non-volatile memory. The example they give in the Espressif documentation that I found, I think it was from Espressif, is a counter. So it'll just say, how many times have we fallen asleep? And it starts with 0. It falls asleep, you wake it up, it says, I've been woken up 1 time, 2 times, 3 times. So it shows you how you can save some stuff, so it's not like a full hard reset. There is some memory between sleeps and wakes. Tyeth asks, how did you get those images, or did you cut and color them? Tyeth, are you talking about the PCB image right here? Maybe. If that's the one you're talking about, yeah, I just took a photo, brought it into Photoshop, and masked out the background, and then made some little hand-drawn traces here. They follow the real traces, but I just color-coded them so that I could keep them straight. Color coding helps me so much. Probably a lot of you too. So then after code the controller, here's the convert the controller section. So we open it up. This is what it looks like, and most of them look the same. They have this connector that is not, you can't pull that out, that's soldered. So you desolder all 6 of these wires. You may have a little resistor package and a capacitor, or just this capacitor, but we take those out, desolder those just to have space, and that also gives us some holes to run some of our wiring through. So you can see, let me jump ahead. Here I'm desoldering, and that's what the little connector looks like after you've pulled it out. But if you've used a solder sucker or a desoldering wick and enough flux and solder, you can get some clean holes there to run these thin wires through. In fact, this was probably the photo I started with. Yeah, I think I took that one and just sort of straightened it a little bit and cut out the background. The chip removal, I don't know if I've mentioned this before, but initially I had left the chip, the PlayStation's own controller in place, and then at one point I started to, as I was pressing buttons, see other buttons getting pressed, and I realized since I'm using pull-up resistors, I was feeding current into the chip, and it was doing stuff. So I was basically waking up the chip sometimes when I was pressing buttons, and so it was doing its own thing. I was like, this is no good. I am just going to remove it entirely. It didn't seem like any of the other passives on here need to be removed, so it was just this guy that I desoldered, and that's a photo of it out already. Here you can see what's left behind here, and I just put a little Kapton tape over there to keep these traces from the foil, the little tracy, coppery bits kind of peeled off. I didn't want them touching each other. That was the reason there, and also anything else that bumps into it we can keep off of there. But you can see, here's how I've got, this was where that capacitor was, so I'm left with 3 drill holes basically. I used one ground, this blue wire at the top here, that's actually soldered to that top hole there, which is ground. Or no, it's this one, sorry, the third one here. You can't see it very well from that angle, but that third hole has a little wire peeking in from the back. That's the ground. Everything else here is just acting as routing holes so I can run my wires through and keep the top neat. And then as I pull these through here, I made 6-8 inch lengths of wire, something like that, soldered them to the PCB of the PlayStation controller, and then fed them through. This wire's thin enough to feed it through the holes on the itsy bitsy where they're gonna be soldered. And I like to do this when I have a whole lot of hand soldering, hand wiring to do, just so that I get the lengths of them all consistent and the routing of them consistent, and I can like double check my notes before I start soldering them. And so those are all just sort of temporarily pulled through, but that means I have, a certain bit of slack that I decided was enough that I could squish it down when I closed it. And then after I had everything soldered to the PCB, I started soldering to the itsy bitsy. Let's see, you might see that here. So you can see there, that blue wire there, I have now snipped it, pulled a little insulation off, soldered it to A2. So that's sort of the labor of that is going through and wiring those all up. And then the LiPo charger gets added, battery gets added, the USB power extension. Let's see that here. Actually, here you can also see now all of my wires have been soldered. There's a couple where there's only one, no, I think there's 2. There are 2 ground pins available on the SP32 itsy bitsy. And so I think I have 3, the need for 3. So I have one from the top, one from the bottom, but the wire's thin enough that they can both be in a single pad hole on the itsy bitsy, and then one down in the other corner on the other side of the board. And the same was true with the USB power pin. I had two things running there, the USB-C breakout and the charger, LiPo charger. Here it is all lit up, up and running. I do not have a power off pin on this. You could, there's an easy way to add a power actual on-off hardware switch to the LiPo charger, and that will turn the whole thing off. But you'd need to drill a hole or do something fancy with a reed switch and a whole rigmarole. I decided not to do that. Game controllers don't tend to have a power button on them. They just have a deep sleep mode, or they're awake and you're playing on them. And then we plug in and charge. To use it, I've got some instructions here that are, I've done this on Windows, on a Windows laptop, as well as on Mac OS. It works pretty much the same conceptually. You just have different menus to go to, but I showed some Mac windows here. So I go to my Bluetooth. It shows up as something named ITZY controller. Connect to it. I used Gamepad Tester to just make sure that buttons were working. And then I go and start in an emulator assigning buttons. So these are the names that those buttons come at, and there's this sort of abstraction layer of the pins that you're plugged into, what those get sent as a game controller, gamepad controller to your operating system. Most of these are kind of what a lot of operating systems expect. You know, button 1 to be A in terms of gamepad, Bluetooth LE gamepad. But you can, in most games or emulators like this one, you can go through and map them however you like, and then play. And so that covers building it. And the last thing was this page that Limor asked me to show using this super cool power profiler. I think we have these in stock, in fact. So if you wanted to go get one for 10% off using today's coupon code of portable, we have 32 of them in stock. We have a maximum of one per customer. So don't hoard these, but you can get one and get $10 off of it, or $9.99.5 off of it or something. So that's super useful for actually determining what the draw is. The current mode on most multimeters isn't going to be precise enough or run low enough to tell you much, but this thing was able to tell me down to the microampere level what was being drawn in the different modes. And you can see the setup here is that I've basically just temporarily powered the itsy bitsy PlayStation controller from the power profiler kit by removing the LiPo plug from the charger, and I made a cable. Comes with this cable here, and I just added a little JST 2-pin battery cable so that I could plug that in and then unplug it and plug the battery back in. So that was how I profiled it, and you can see here, I showed these on Show and Tell last night, but these are pretty cool. It's pretty interesting. You can see here, if I zoom way up, that's the current draw when I'm playing. And you can see there are some little spikes here as the radios are sending out little happy pings or you're pressing buttons. But the average there was 123 roughly milliamp. So that's what gives us about 3 hours of gameplay if you were to just play straight through. And then if you look at the deep sleep, once I figured out turning off the ESP Wi-Fi as well as going into deep sleep mode properly, then we're down here. This is it sleeping. So there you can see I've got almost 3 seconds that I've sampled there, and it's giving me an average of 76.94 microamperes, which is 0.07 milliamps. So huge difference, and that's how I arrived at this right here, which is my 350 milliamp hour battery with 0.077 milliamp draw when it's in deep sleep mode. And this is the cool battery life estimator or calculator that's on the DigiKey site, which says you get about 6 months if it were just sitting there. discharging the battery very slowly. So before I had figured that out about turning off the Wi-Fi radio, this is what deep sleep was looking like, 1.83, and that's not right. That's way too high. It shouldn't be drawing that much in deep sleep. So now I know. That's the key, ESP Wi-Fi stop. And there you have it. That's the building of the controller. Now I can play games on it. So let me know if anyone has thoughts or questions in the chats. Over in the YouTube chat, we've got a question from Tyler Darlington. A while back you showed using a rotary encoder to make a shuttle jog for your video editor. Is there any chance you could do something like this and make the code available? Thanks for the question. Yeah, so I think, I'm trying to think if we have a Learn guide that's close to this. So I've done this kind of project a couple different ways, and sometimes I'm looking here for, do I have a rotary encoder? I don't think I do. I've used some of our rotary encoder breakouts and things like a Cutipie to just send USB HID key commands. So with every increment of turning, it'll send maybe the right arrow key. And on turning it backwards, with every click, it'll send the left arrow key. And in most video editors, I use Premiere, most video editors, there's something like arrow or period and comma that frame advance and frame back. So you can turn that and it's just sending a string of those. And it'll allow you to scrub back and forth. And then you can do something like, if it's a click encoder, when you press it, it will hit the space bar, which is play in a lot of video editors. Let me look and see if we have anything that's a, look up rotary encoder. Let me hit enter on that. If anyone remembers, type it in the chat. Okay, yeah, so here's one that Todd Kurt did. This is on his TBot GitHub, github.com/TodBot. This is called Cutipie Knob. And this does exactly that, and Todd actually 3D printed a super cool knob and enclosure for it and added a NeoPixel ring, so it's super fancy. This is probably one of your best bets, and this uses CircuitPython and the USB HID to send commands. I believe that's what you did. He may have done it with media, USB HID media controls, which can do things like volume up, volume down, which are not normal HID stuff, like not keyboard HID stuff. But yeah, there's that's an example of that. I showed at one point, and I can bring this back, and I've actually been meaning to do a different version of this, but I had a MIDI-based jog wheel encoder that was actually from Disney Animation when I worked there. I got it from like a recycling closet that someone said, you can take this. So it's actually a J.L. Cooper. Let me look that thing up. It's pretty cool. J.L., it's in my other office, so I don't have it right here. Jog Wheel. I'll show you this. So they make a bunch of them. These are the sort of newer ones. This is the kind I have right here. It was called the Media Control Station. And so it came in 3 flavors. There was a USB version, and then there was the MIDI version and an RS-422 serial, like 9-pin version. I have one of those. I haven't used that one for anything. I got it cheap on eBay. And then I have the one that was originally meant to be MIDI. For that project, what I did was I have a Feather, it happens to be a Feather NRF 52840 for some reason. I'm not doing anything radio-wise with it. But it is reading the incoming MIDI, so that control station, when you're doing the jog wheel, is sending, I forget what MIDI command, sort of in these bursts. And then the same with those keys, they send like MIDI CC on-offs. So I just interpret those and send out USB HID. So that's how that project works. These are nice largely because the encoder wheels are great. They're stepless. I think some of them might be optical. Much better for this kind of spinny stuff. You can even hit bzzz and it'll spin real fast. So I hope that answers your question, Tyler Darlington, and I hope you're still here. You asked that a little while ago, I think, in the chat. If you're not, maybe you'll hear about this later. But yeah, let me know if anyone has other suggestions on Rotary Encoder projects that are similar to that. TBot said that there is a set of examples over in the Adafruit Learn System Guide's Rotary Trinky. And you can see there's cap touch, color picker, volume knob, YouTube frame example. So this one sends, I think, the period key and the comma key to advance YouTube back and forth. So go check those out. Those use that little rotary Trinky, but they would be, you could use those in any hardware setup in CircuitPython pretty much. All right, let me a sip of water here. So, the reason today's coupon code is portable is, you can see it right there, maybe you've been looking at it. Someone gave me recently that little portable television. Whoops, I'm moving the wrong thing around. Hold on, I'm going to move this over to the side. So this right here is a portable television radio cassette player. Is there anything else it has? I think that's it. So you can see there's a little 5-inch color CRT, which is way cool. I have a few small CRTs. They're all black and white. This is the smallest one I've got, and it happens to be color, which is incredible. This was from Brocksonic, and I'll show you a top view in a second so you can see it a little better. But we've got color screen there. It'll be a bit washed out with that light, so I might turn that off. We've got a cassette up on top here, and then we've got different shortwave, medium wave, and FM radio that you can dial in there. And so this is cool on its own, but someone on social media asked me about playing Nintendo Duck Hunt on it. And so I had shown there's that light off. I had shown a image of Duck Hunt just running its attract loop on this. And I'll show you how this is hooked up in a second. But he said, well, I wonder if the light gun will actually work on that tiny little screen. And so let me turn the TV on there. It's going to take it a little moment to warm up. And come around this side so I actually shoot at the thing. And I'll go ahead and zoom in a bit too. This thing has a beautiful screen. It's got you're going to see some refresh rate based stuff where it's going to battle my my camera's shutter speed. They're not exactly in sync, but it's a really good looking screen. I've got this little add-on since this was meant to be taken out portable, and this can take batteries. I don't have any for it. This is meant to block the sun, so if you're trying to watch your soap operas or your stories or your baseball game or whatever on there, you can maybe block a little bit of sun. Speaker built on top, so you can turn the volume knob up here. And so let's look. Can you play Duck Hunt on it? Got that up and running. Start. Okay, let's see if you can see this. I've got the gun here. Let's see if I can not block the camera too much. All right. Boom! Oh, yeah. Oh, he got away. So yeah, it's not like it just auto hits the screen. It's precise enough that you really can still play the game, which is pretty cool. See how far away I can get. Yeah, it still works. How about that, huh? I'll keep this in the frame. I'm just shooting from the hip there. You can't quite see. Let me see if I can align that. There we go. Darn you. All right, let's see if we get one more try. Got him. All right, I know it's violet, but so Nintendo Zapper, CRT. These only work with a CRT, so now I've got nearly portable gaming. I can play games portably with this. and a battery, and I'll need some sort of transformer or to convert this to a DC power for the Nintendo itself. I guess you could run that off of batteries, right? I think it takes a 9 to 12 volt, or no, AC. I think this runs off an AC and not DC. Can't remember. NES is a little weird. But there you go. So there's the TV. The radio and tape deck are not that interesting, but they work. But let's turn TV off there. I'll show you the behind the scenes on this thing. Let me turn the lights back up. TBot says if you back up far enough, every shot is a hit. Is that cheating? Where's the fun in that? Let's turn this light back up and I will zoom out on here. And let's see if I can maybe fix that other camera too. Mirror. There we go. So I have a RF converter. I'm using the composite out because the box I'm using for RF conversion is a little RF modulator from Radio Shack that expects a composite in. I know that the NES has this RF out, and I don't know what, I haven't even experimented with that. I don't know what that is expecting to go through on the way to the TV. So this has a little external input that I have a coax cable connected to. So this can use its internal antenna or this right here, which gives us a VHF out through the little RF converter pigtail there. And then it's got a nice handy handle on it. So you can pick that up and carry that around. Perfectly portable gaming. And I think it uses, so this is a 12 volt, either straight AC or it has a 12 volt DC center negative DC barrel jack. It can be switched between 120 to 220. And it has a switch here for normal or charge. So in charge mode, it could ostensibly charge up whatever batteries you're expected to put in this. This was made June of 1983. Rechargeable battery pack only. It was 1.5 volts times 10. Huh. And then it has a model number for a battery pack. So there's some sort of kooky battery pack that went in here. One battery went down here and then 9 up here. Wild. I don't know much about that. I haven't even looked. The manual may say. I got the manual with this, which is pretty cool. Right here. Portable color TV, radio, cassette, tape, recorder, player. Serial number on here. This is obviously a great find because someone took really good care of this, loved this. Tells you how to tighten your cassette with a pencil or pen. And I think it may have info about the battery. It says car battery. Oh, so there was also a car battery 12 volt to cigarette lighter socket adapter for power as well. So that's probably what that 12 volt is intended to be. Had a 90-day guarantee, was bought in September 20th of 1983, so that has expired. But what a beautiful little piece of gear, and so well cared for that it just works, including the tape player. I'm not sure how good the belts are. The sound pitch might be a little off, but it actually did play when I tried it. I may goof around with that a bit. But there you go. We now have portable gaming. All you got to do is pile all these things up, and there we have it. I don't have a project based on that. I'm actually still working on that there, the tank stick with the Pico in it. And I just wanted to give a little update on those. So that's let me know if you have any questions about the TV there. But that's pretty much all I wanted to do was do a little show and tell of that thing, which is pretty cool. Some Nice says 12 volts makes sense. I think those were popular in RVs. Yeah, for sure. Let's see. Oh, jumping back a little bit, Tyler Darlington said, I'm still here. Thank you for your answer. Very helpful. Trying to make a DaVinci Resolve speed editor, but with Adafruit parts and just the shuttle jog part. Okay, yeah, that may be your way to go, is look at some of those CircuitPython Rotary Encoder projects. Those are what you want, and then Resolve will have keystrokes that you can look at for basically whatever your frame advance is. If you use arrow key or some letter or the period key and back, whatever those are, you can assign those to the Rotary Encoder, and then every time it increments forward, it taps the right key, increment back, or decrement back, it taps the left one. That's how I have it working in Premiere. The only limitation there is that it seems like you can't spam those keys as fast as you can turn it. So at some point you're trying to turn faster and faster, and it's just it's not keeping up with it because it's just getting keystrokes, and that's not as efficient as a dedicated control surface for a video editor that's going over MIDI or some other non-HID keyboard type of control. A lot of those are Mackie control surface protocols. So if you can look into that, there may be a way to do it. But I use mine in Premiere all the time, and it works great for me. So the thing I was referring to back there is that tank stick, which you can see under the monitor there where I got a game going. In fact, let me point the camera over there. Let's zoom in. Let me show that in action. So you can see here I've got emulator here with Scramble, and oh, this is a hard game. So I've got this set up now. I had a couple of keys swapped last week when I was trying to show the config, but I've now got my start button up here that will, if that's held when I'm restarting, that'll give us the configuration for GP 2040, which is what I was looking for last week, and just for whatever reason couldn't get it working, partly because I had a couple pins swapped. So let's, I'm just gonna pause this. Since this is an arcade game, there is no such thing as pause based on these controls. But what I wanted to do was show you on a fresh Pico what the GP 2040 setup and config looks like. I think I covered this before when I was doing the switch controller, the little Pokeball thing, I think. So this is a similar thing to that. But what I have here is, this is a Pico H, which is just a regular Pico, but comes with the sort of snazzy pre-soldered header on there that has these little cross beam supports for strength, I guess. I don't know why it's so extra, but there it is. Probably easier to pick in place or something. And maybe I'll put that on a breadboard to make it a little easier to just tap some of the buttons on. So let me show you. Get this set up here. Oh my God, this is the world's strongest breadboard. I have to use like spudgers to remove. That's so not fun to remove. And maybe I should have switched over to this one, which I had already made a bunch of labels for, but that one's wired up for something else, so we'll leave that as is. And focus there. So what I'm going to do is, yeah, love this silk screen, so unhelpful. Oh my gosh. Well, 3 down from the top is a ground, so that's helpful. I can do well, the Pico H doesn't even have some of the little markings I think the other Pico does. Luckily, in the real project, I'm using the terminal block breakout, so I've got plenty of space and easier silks. But so yeah, 3rd pin there, that's a ground, and so now I'll be able to ground this to GPIO switches to start it. And I'm going to switch this view here to a browser. And if I go to GP2040, downloads. So this is a regular Pi Pico. I'll hit download here. And I'm going to grab a USB micro B cable. It's plugged into the computer. I will hold down the boot select button and plug this in. That'll put my Pico into bootloader mode, which means I can drag that UF2 onto there. A quick aside, thank you, Todd recommends this. If I had a printer in here, I would do this immediately. Yeah, he's got a nice little printout. You can make it as a sticker or a label to plop on top of your Pico, so you know what your pins are. So I've now got the RPi. What is it called? There's a drive that shows up called RPi RP2. Which is the bootloader drive. I can now drag the file. You won't see this, but I'm dragging the GP2040 firmware onto it. And when I do that, and go to Gamepad Tester, we should see a gamepad show up. Happens to be showing up in tab 2 for some reason. So this is now actually in PS4 mode, which is, I guess, the default now. And so as I'm shorting buttons here, it's pressing buttons B8, B9, and so on. But the cool thing is I can now hold down that start button, which is pin 17, I think, while I plug it in. And that puts it into config mode. So if I look at web config, this is the address 192.168.7.1 of the board itself. Will I get it to work this time? Am I cursed? Let me unplug that again. This only doesn't work when I'm on camera. It's my USB cable. I don't think I tested it in here since last time. All right, hold on. Just try plugging the other end of this USB cable. Okay, so I'm gonna short that pin, plug in, give it a moment. Maybe I was being too quick about it. And I'm cursed. Is that not the default? I think that is the default. Maybe this is my new bit. Every week I will pretend like I know how to get this thing into config mode and then fail. What is up with you? What is up with you, thing? Oh, it came up. I don't know why it was taking that long. Maybe this was happening all along. That's very strange how slow it is. Or it could be the first time, because maybe it's loading all of that off of the Pico. I was just jumping the gun. Anyway, there it is. So, yeah, I bet that's the case. Oh my gosh. Maybe it was just the first time. It takes a while, and then it caches all this in the browser. You're the web config, right? Oh, no, you're not. nope. Bye, some nice. Gotta leave now. Maybe I should leave now and get this working before I try. Okay, I'll give it one more shot, and then I'll plan better for this to actually work next week. So plugging you in while holding S2. Who knows? Maybe it just doesn't work on this computer with some config I have, because it's on the other, in my studio space inside that I was doing this. Yeah, that's mysterious. All right. Could you be a different pin? Nope. All right, we're in a tailspin. I'm going to stop there. Next time, I will have a better prepared, just to show you what those config items are. It's things like getting it to boot up as a direct input device instead of a PS4, a few of the pin assignments if you want to change them based on the joystick you're using, and things like turning on the LED, which I wanted to use when I have buttons being pressed. So there's a few cool config things that we can do, which I will run next time. So that will do it. Sorry about that, but we'll have that ready and better for next time. There is Todd's Pico plate he mentioned there. And I think if there's no other questions in there, we'll wrap it up. So that's the show. Thanks everyone for stopping by, indulging some of my retro gear fetish or whatever is happening over there with the CRTs. And there will be a deep dive with Scott tomorrow. If you want to come by, check out some of the development he's doing. Should be at 2 p.m. We will be back on Tuesday with a product pick of the week. There may be a Desk of Lady Ada sometime on the weekend, maybe Sunday night at various hacker times. And then on Wednesday, we'll be back with the 3D Hangouts. I think they're back next week. They were off this week. And then we'll have the Show and Tell, Ask an Engineer, and more. So thanks, everyone, and see you next time. Bye-bye.